So obviously on this worksheet we're focusing in on canceling out what's on top and bottom, what's on the numerator and the denominator. It's kind of like subtraction, and you see what's left over where. And we also have the power of 0. Anything to the power of 0 is a 1, so you could just scratch it out. And we also have negative exponents that need to move from one side to the other side and they become positive. So just a quick example of each. Number 2, the a's cancel, right? Because there's one a down here that cancels out with one of these 4, and there's going to be 3 left over up on top. Now all 3 b's on the bottom cancel out with 3 of these, and there's going to be 3 left over up on the top. Now if you think about this, what's left over up on top? There's an a to the third and a b to the third. On the bottom there's nothing left, so you could put a 1 if you'd like, but when there's a 1 on the bottom you don't really need it. It's just a to the third, b to the third. Because when you have a 1 on the bottom, if you divide by 1 it's that same exact value. If you say 2 divided by 1, that's actually 2. If you say 10 divided by 1, it's actually 10. So a to the third, b to the third divided by 1, it's actually a to the third, b to the third. Let's not be mistaken when it comes to negative exponents. You have to move them from one side to the other. So if we take a look at number 10, for example, we do have negative exponents. You could decide to move them first and then apply different rules, or you could decide to use rule 1 of exponents. Okay, so number 10 could be done different ways. One way of doing it is to say, I'm going to take the x to the third and multiply it by x to the negative 8. Right? I know I'm supposed to move that negative 8 down to the bottom, but if I want to use rule 1 of exponents, rule 1 says that when you're multiplying with the same base, you simply combine the exponents, you add the exponents. So if you think about 3 plus negative 8, that's really x to the negative 5. And then of course you would have what's left over, the y to the negative 5, right next to it. So you really have x to the negative 5, y to the negative 5, and you know that both of those have to go down to the other side. Both of those have to go down. So your final answer will be nothing left up on top and an x to the 5th, y to the 5th on the bottom. Okay, that's one way of doing it. Let's say you didn't want to do it that way. Let's go back to the original. Maybe you did want to just move the negative exponents to the other side right from the start. So you can move this one down, and the x to the third would stay where it's at. So I would put a fraction bar like that, keep the x to the third up on top, and then put the x to the 8th on the bottom, and the y to the 5th on the bottom also. Wow, that was ugly. So here's our answer so far. X to the third over x to the 8th, y to the 5th. But then you could also apply the canceling rule. The x to the third, there's 3 of them up on top, which could cancel with 3 of these 8. And of course you'd have 5 left over. So your final answer is the same thing. Nothing left over up on top. So that means you have to put a 1 up there. And x to the 5th, y to the 5th on the bottom. So it depends which rules you want to apply first. Right? As long as you're applying a rule correctly, it doesn't matter which ones you apply first. You should get to the same answer at the very end. Okay, which question do you guys want to see?
There's a mistake on 25.
There's a mistake on 25?
There's different numbers in the equation than the answer.
What numbers does the answer have on the answer page?
-2 instead of 3 for R.
For R? So a -2 up here or down here?
At the bottom.
On the bottom? So, okay, apparently there's a typo right here. This 3 should be a -2. Is that how it is on the answer spot?
Yeah.
On the answer page? Okay. So let's actually go back and treat this as r to the -2, the way it should be, because that's how it is on the answer page. So that was a typo. Should we work through this guy?
Sure.
Okay. So there's many different ways of approaching this. Okay? You could use the rule where you take the outside exponent and distribute it to each of the inside exponents. You could do that if you wanted to. Or you could work on the inside, cancel things out, move things around, and then at the very end distribute the -5. Or you could even change this to a +5 right now and just flip the fraction, right? And change that to a +5 so you don't have to worry about a -5. It's up to you guys. You guys want to distribute first? Okay, let's distribute first, right? If I distribute that -5 to that negative power of 1, distribute the -5 to the 3, distribute the -5 to the q, distribute the -5 to the -2. Remember, power to a power you multiply. So you're really going to have, up on top, you're going to have q to the +5. Why? Because -1 times -5 is +5. And then you're going to have r to the what? R to the -15. Because 3 times -5 is -15. And then the q down here, the q is going to have what power? -5, because there's an invisible 1 right here. 1 times -5 is -5. And last but not least, r to the what? R to the +10. Now, why +10? Because a -5 times the -2 that it's supposed to be -2. That gives you a +10. So in this case, it wasn't that bad to distribute the -5. We still need to apply other rules, and the other rules are moving negative exponents to the other side. So I want to take this r to the -15, and I want to move it right next to the r to the 10th, and it's going to become r to the +15. I want to take this q to the -5 and move it up, and put it right next to this other q to the +5, and it's going to be q to the +5 times q to the +5. So let me rewrite my fraction so far. I have q to the +5 that I moved up right next to the q to the +5 that was already up there. And on the bottom I have my r to the 10th, but I'm also going to move down that r to the -15th, and it's going to become r to the +15th. And last but not least, I'm going to apply rule 1, which is when I'm multiplying with the same base, all I need to do is add the exponents. Multiplying with the same base, add the exponents. So my final answer for number 25 should be q to the 10th over r to the 25th. Q to the 10th over r to the 25th. 10 right there. Any other ones that you guys would like to see? 23? All right. So we do have parentheses here with an exponent on the outside. Let's distribute that outside exponent to both terms on the inside of the parentheses. Okay, now remember, a power to a power you multiply. A power to a power you multiply. So -4 times -1, that's +4. -4 times +3 is -12. So let me rewrite my fraction. There's my fraction. But instead of -1 right there on the j, I'm going to have j to the +4, because -4 times -1 is +4. And instead of k to the third, I want to have k to the -12. Because -4 times +3 is -12. And then I want to rewrite my j to the third, k to the third. There's other rules that I could apply. One rule is the canceling out rule, the subtraction rule. If you think about it, you have j's on top, j's on the bottom. You have 3 on the bottom and 4 on the top. So 3 j's cancel out with 3 of these, and you're going to have 1 j left over. And not only that, I still have a negative exponent. I need to take that negative exponent, grab it, move it to the other side. I'm going to put it right next to the k to the third. So what do I have left? On top, I have just a nice, beautiful j. On the bottom, I have my original k to the third, and I moved down the k to the -12, and it became k to the +12. And once again, my final step here would be to multiply k to the third times k to the 12th, giving me a k to the 15th on the bottom with the j up on top. How does that taste? Pretty good? Okay. Which other one? Jumping to number 27. Again, it depends on which rule you decide to apply first. You could distribute the -2 to each and every term in there, right? But then you're going to have a bunch of negative exponents, then you got to move those negative exponents from one side to the other. So it might be a good idea to start with the inside of the parentheses this time. Cancel out anything you could cancel out and move anything that you could move on the inside, right? So let's actually begin that way. Let's start by looking at the inside. There's an x to the third up on top and an x to the fourth. There's 3 x's on top, 4 x's on the bottom. All 3 x's cancel out with 3 of these, and you're going to have 1 x left over on the bottom. There's 1 y down here, and there's 2 y's up here. So this 1 y completely cancels out with 1 of these, and there's going to be 1 y left up on top. And for the z's, I have a z to the negative 2. I want to move that up right here, and it's going to become z to the positive 2 times that other original z that was up there. Okay, so since I sketched it in there, I'm going to just scratch it out. Does that make sense? I moved that z to the negative 2 up. Now it's right next to the other z. And of course, when I rewrite what I have, I want to have a 2 left over. So let me put 2 right there. I have y to the 1, because it's a y to the 1. And how about, what do I have here? Z times z squared. Z to the third. Okay. So we have 2y to the 1, z to the 3, over what's left on the bottom. There's a 3, there's an x, and that's it, because this one moved up. So there's a 3x on the bottom. So here's our, that 2 came out weird. Let me scratch that out, put a bigger 2 right there. There you go. So forget about this right here. Okay, so we have 2y to the 1, z to the third, over 3x, and we still have to the negative 2 power on the outside. Now, one option is to distribute the negative 2 to each and every term. That's to the 2, to the y, to the z, to the 3, to the x. And then take all of those negative exponents, because they're all going to have negative exponents, and flip all of them, right? Or another option is to just take that negative 2, make it positive 2, and flip the fraction right now. What do you guys want to do? Distribute the negative 2 and then flip, or flip and then distribute? Flip, then distribute? That's what I would do. So what I want to do is I want to rewrite my expression, but instead of a negative 2, I want to make it a positive 2. Now, why is that? Because I'm going to flip the fraction. Okay, so I'm going to flip and then distribute. You could distribute and then flip. It's up to you. I'm going to flip and then distribute. So I really have a 3x on top and a 2y z to the third on the bottom. So I flipped. Now I'm going to distribute. So I'm going to distribute that outside exponent of 2 to each and every, I'm talking each and every term right there. Okay, so my final answer equals is going to be 3 squared. 3 squared is really 9. X squared, that's on top. On the bottom I have 2 squared, which is a 4. Y squared, because y to the 1 to the second, you multiply y squared. And z to the what? 6. There's my final answer for that question 27. Is it hard? No. Is it fun? Yes. Okay. Is there any other ones you'd like to see?